All right, picking up where we left off. So example number 5 for lesson 3.2. All right, y'all aren't going to like this one, but y'all will get over it. Remember how in the last lesson we couldn't have a square root in your denominator? Well, you can't have an imaginary number in your denominator. Denominator. Y'all got it. All right, because I ran out of space. All right, anyway, so what does that mean? Well, we can get rid of this I by using this rule right here, I squared equals -1. So if we can make this an I squared, we can turn that into -1 and we can get rid of the -1 or the negative I in your denominator. So here's how we do it. So we basically need to multiply this by I squared. So what we're going to do is we're going to multiply by the conjugate. All right, the conjugate is, if you look up here, pairs of complex numbers of the forms a plus bi and a minus bi, where b cannot equal 0, are called complex conjugates. So we're going to use this definition down here. I just put it up there to save space. Well, because we had that too. So I was just trying to keep this last year was like 3 or 4 pages long, so I was trying to make it shorter. All right, so what we're going to do is we're going to multiply this bottom by the conjugate, and that's going to help us to get rid of the I. So Ms. Gill, what do you mean? So let's rewrite our problem. We got a 4 plus 3i over a 2 minus I. So we're going to multiply our numerator and our denominator by the conjugate, which is 2 plus I. All right, so why are we able to do this? Well, remember, any number over itself equals 1. So this is essentially, we're multiplying this by 1 just in this format. All right, so now we're going to take what we just learned and we're going to do it twice. So we're basically going to have 4 plus 3i times 2 plus I. And then on the bottom, we're going to have 2 plus I times 2 minus I. Now, if you look up here, anytime you have something like this, your middle terms cancel out. So essentially, you're doing a squared and b squared. For those of you whose brain can work this way, go ahead and do it like that. But you can also do FOIL or box method too. Okay. All right, so we're going to work out this first part. I think I might do this one FOIL just because of my space instead of doing box method for both of these. Plus for, I don't want to leave out the people who actually like FOIL. So we start off with 4 times 2. So 4 times 2 gives us 8. Then we do 4 times I. So that would give us positive 4i. Then we move over to this term. So we got 3i times 2. That gives us 6i. And 3i times I. So that's going to give us 3i squared. I do notice, like, if I keep my finger there, it kind of helps me too. So if you like this and you don't want to lose your terms, or just know you got 2 and 2, so that means your answer should have 4. That could be another way if you like it this way. All right, so we're going to take 2 and we're going to multiply it to this 2 and we get 4. We're going to take this 2 again, multiply it to the I, and we're going to get negative 2i. So this one, we got a positive I. So we're going to take this I, multiply it to 2. We get positive 2i. And then I times negative I is going to give us negative I squared. So we do have opposites right here. Negative 2i, positive 2i. That's what I was talking about up there. We know that we can rewrite these I squares with -1. So that's what we're going to do here. So we have 8. I can combine these two terms together, so I'm going to go ahead and do that now. So I have 4 plus 6 is 10, plus 3 times -1. Could you skip writing the -1? Yes, but for note purposes, I want you to know how we went from one thing to the other. Then we got 4 minus, so if there is none, there is 1. So technically that's a 1 times -1, right? Because if there is none, there is 1. So technically that's a -1i. And now let's simplify. So we got 3 times -1. So that becomes -3. -3 plus 8 gives us 5. And then we have plus 10i. And then in our denominator, we have 4 times -1 times -1 gives us +1. So 4 plus 1, which is 5. Don't know why I was trying to write 4 and 5 in the same one. Well, let's just go ahead and add it together. We know that negative times a negative gives us positive, so 4 plus 1 gives us 5. So we can actually simplify these. So if you think about it, whenever you add fractions, your denominator is the same. Think about it like you're splitting them up like this. And you can simplify. So 5 divided by 5 gives us 1, and 10 divided by 5 gives us 2. So we got 1 plus 2i, and that is our final answer. So I just find it easier at this point, instead of, you can look at it this way, but to teach it, I just find it easier to separate them, just like you learned how to combine them when it came to the fractions. And I checked to make sure I wasn't making any magic happen with this one. Don't know what I got going on lately, but that is what it is. All right, so moving on to example 6. All right, so 6 is very similar to the last lesson. It was like the first example in lesson 3.1. So we're doing it the same way. We're solving for x squared. So our first step would be to subtract 4 from both sides. All right, this should seem a little familiar. So x squared is equal to 0 minus 4 gives us -4. So here's where we couldn't finish in 3.1. So we're going to take the square root of both sides. All right, remember square root and squaring, they cancel each other out, leaves us with x equals plus or minus the square root of -4. But now we know that it doesn't have a real solution, but it does have an imaginary solution. And now that we know how to find the imaginary solution, that's what we're going to do. So x is equal to plus or minus, we are going to break this up as -1 times 4. So we know the square root of 4 is 2. We know that is I. So we get x is equal to plus or minus 2i. And this would be your answer. All right, so if you want to pause and give this one a try, go for it, because you should be able to solve that one without me. All right. If you didn't pause your video, or now you're just checking your answer, welcome back. All right, so plus 11 on both sides. That leaves us with 2x squared equals -36. Then we're going to divide both sides by 2. And we're going to get x squared equals -18. So here's where we are going to now take our square roots. So now we have x is equal to plus or minus the square root of -18. So we can actually break -18 up. We're going to break it up into -1 times 9 times 2, because 9 is my perfect square. So I'm going to finish my work over here. So now we have x equals plus or minus. We know square root of 9 is 3, and that's an I, so 3i times the square root of 2. Again, notice my I is in the front and not to behind. Do not leave it behind. Put it in the front. All right, so what does this mean? You could say, because I just want you to know what it will also look like, just plus or minus does mean that you have positive 3i square root of 2 and x equals -3i square root of 2. I just want y'all to realize that that's what this plus negative means. Okay? So very similar to the last one. All right, this one is very similar to the last lesson as well, where we looked at our graph, we looked for the x-intercepts. No x-intercepts, right? So what does that tell us? That tells us that our zeros are going to be imaginary. So, there's no real solution, right? There's no real zeros, but there are imaginary ones. So that's what we're going to do here. So same idea as we did last time. It's set equal to 0. That's your first step. All right, so this one is set equal to 0, but maybe your future ones may not be. So make sure it's set equal to 0. And we are going to subtract 20 from both sides. Oh, why did I say that? This one doesn't matter if it's set equal to 0, does it? No, we're solving. Okay, but for other ones, I'll just leave it there. Who knows? Miss Gill has her moments. I get problems. We do so many problems that sometimes I mix them up. All right, so we got 4x squared. Again, I'm human. I make mistakes. Not perfect. All right, so we got 4x squared equals negative 20. We're going to divide both sides by 4. And we get x equals negative 5. No, we don't. We get x squared equals negative 5. Whew. All right. So now we're to this point. All right. So we are taking the square root of both sides. We have x is equal to plus or minus the square root of negative 5. Now there are no positive, no factor. Oh, okay, lady. 5 is a prime number. That means the only factors is 5 in itself. I don't know why I'm struggling. So we're going to rewrite this with the I on the outside and the 5 on the inside. Don't know. So our zeros are I square root of 5 and negative I square root of 5. Goodness gracious. See, this one was a little over 10 minutes, but that was because Miss Gill made some mistakes. I can't even talk. All right, glad this video is over. All right, I will see you guys in class.